Hi, I'm Aneka. Our project explored how lifestyle habits and demographics relate to obesity levels using the UCI obesity dataset. The goal was to identify key behavioral risk factors and visualize patterns that could support more targeted public health interventions. I learned how critical a well structured exploratory data analysis is for shaping meaningful public health insights. By examining the data, I identified that behaviors such as FAVC, encoded as frequent consumption of high calorie food, and SCC, encoded as calorie monitoring, were stronger predictors of obesity than variables like age or screen time. To ensure these patterns were reliable, I cross validated trends across multiple visualizations, including histogram, box plot, correlation matrix, and peer plots. This helped confirm that the findings were consistent and not influenced by noise or anomalies. Overall, the process reinforced how behavior focused insight enabled more precise public health recommendations rather than generic interventions. The main challenges that I faced included a portion of the data set was generated using smooth, which increases class balance and can exaggerate certain behavioral patterns. Variables like FCVC, encoded as frequency of vegetable consumption, and NCP, encoded as number of main meals, were stored as a numeric code, but represented other categories, meaning they required careful interpretation to avoid assuming linear relationships. I approached these challenges in two ways. I did a cross validating patterns to manage the synthetic bias. I confirmed the behavioral trends using multiple visualization and summary statistics. This helped distinguish genuine signals from patterns that may have been amplified by synthetic data. I verified the meaning of each encoded variable and used statistical approaches suitable for ordinal features. This ensured that our analysis reflected true behavioral relationships rather than assumption based on numeric values. No recording was needed for categorical variables, which kept the workflow efficient. With more time, I would extend the project into predictive modeling by training classifiers such as random forest or XGBoost using the most influential behavioral risk factors. I would also apply clustering techniques to develop a behavioral risk score for public health providers and design interactive dashboard to help stakeholders explore and understand the data more effectively. My strengths included technical problem solving, project organization, and clear communication. I ensured the workflow was structured and smooth, analysis were properly documented, and insights were translated into actionable recommendations. I focused on bridging the gap between raw data and strategic conclusions so that the team's output was cohesive, accurate, and meaningful. Thank you.